Your grandfather's cleaning rod just scratched $1,500 worth of barrel coating. The cotton patches he swore by are leaving fibers in your trigger mechanism. And that gun oil he passed down? It is turning your precision firearm into a dirt magnet that jams every 50 rounds. The cleaning methods that kept World War II-era rifles running in foxholes are silently destroying today's firearms. Modern pistols and rifles use advanced metallurgy, polymer components, and specialized coatings that simply did not exist when your grandfather learned to clean his Springfield or Garand. What worked on steel and wood can ruin titanium nitride coatings, damage polymer frames, and turn precision tolerances into sloppy, unreliable mechanisms. The firearms industry has evolved dramatically in the past 20 years, but many gun owners are still using techniques from the 1940s. The result? Expensive repairs, decreased accuracy, and firearms that fail when you need them most. These are the 5 old-school cleaning habits that are quietly destroying modern firearms. Number 5. The one-size-fits-all cleaning approach. Walk into any gun shop, and you will see it. The same cleaning kit marketed for everything from .22 pistols to 12-gauge shotguns. The same brush, the same patches, the same solvent for every firearm in your safe. This approach made sense when most firearms shared similar construction methods and materials. But modern guns are built like precision instruments with specific requirements for each component. Your AR-15 upper receiver uses different coatings than your polymer frame pistol. The stainless steel barrel on your precision rifle needs different care than the chrome-lined barrel on your defensive carbine. The trigger mechanism in your striker-fired pistol has tighter tolerances than the hammer-fired revolvers your grandfather maintained. Using the same cleaning approach for all of them is like using the same motor oil in a Ferrari and a pickup truck. The problems start small but compound quickly. That bronze brush that works perfectly on your steel revolver cylinder? It is too aggressive for the aluminum frame of your modern pistol, slowly wearing away the anodized finish with each cleaning session. The solvent that strips carbon buildup from your rifle gas system attacks the rubber seals in your pistol's striker assembly. The patches sized for your rifle bore bunch up in your pistol barrel, potentially leaving fibers that affect accuracy. Professional armorers and competitive shooters learned this lesson years ago. They maintain separate cleaning kits for different types of firearms, with specific tools and chemicals chosen for each gun's materials and construction. A precision rifle gets careful attention with appropriate solvents and soft brushes. A hard-use defensive rifle gets more aggressive cleaning to ensure reliability. A polymer frame pistol gets specialized care that will not damage plastic components or rubber seals. The solution requires rethinking your cleaning setup. Instead of one universal kit, consider the specific needs of each firearm in your collection. Read the manufacturer's cleaning recommendations, which often specify compatible solvents and discourage certain chemicals or tools. Group your firearms by similar construction and materials. Then build appropriate cleaning kits for each group. The upfront investment in proper tools and chemicals costs far less than repairing damaged finishes or replacing worn components. But using the wrong tools for each firearm is just the beginning of how old habits damage modern guns. Number 4. Ignoring the unique needs of polymer components. The black plastic frame of your modern pistol looks tough, but it requires completely different maintenance than the steel and wood firearms that dominated the market for over a century. Polymer components have revolutionized firearm design, making guns lighter, more durable, and resistant to corrosion. However, they also introduced new vulnerabilities that traditional cleaning methods can exploit. Many gun owners treat polymer frames like steel components, subjecting them to harsh chemicals and aggressive scrubbing that gradually weakens the material. The polymer used in firearm frames is engineered for strength and chemical resistance, but it is not indestructible. Certain solvents can cause stress cracking in polymer components over time, especially around high-stress areas like the trigger guard and magazine well. The most common mistake involves using chlorinated solvents or brake cleaners on polymer frames. These chemicals, commonly found in older gun cleaning products, can cause immediate damage to polymer components. The damage often appears as white stress marks, hairline cracks, or areas where the surface becomes chalky or brittle. Once polymer begins to degrade, the damage spreads through the component, potentially leading to catastrophic failure. Even seemingly mild chemicals can cause problems over time. Many traditional gun solvents contain ingredients that slowly leach plasticizers from polymer components. Plasticizers keep polymer flexible and impact resistant. When they are removed by repeated exposure to incompatible chemicals, the polymer becomes brittle and prone to cracking under stress. Temperature also affects polymer components differently than steel parts. Rapid temperature changes, like immediately cleaning a hot barrel with cold solvent, can cause polymer components to expand and contract at different rates than metal parts. This thermal stress can lead to cracking around pins, screws, and other attachment points. Professional gunsmiths who work extensively with polymer frame firearms use specialized cleaning products formulated specifically for modern materials. These products clean effectively without attacking polymer components or the various rubbers and plastics used in modern firearm construction. They avoid harsh solvents in favor of surfactant-based cleaners that lift contaminants without chemical interaction. The key to maintaining polymer firearms involves using compatible cleaning products and gentle techniques. Warm soapy water actually cleans polymer components more safely than many commercial gun solvents. For stubborn fouling, specialized polymer-safe degreasers remove contaminants without damaging the frame material. Always allow polymer components to return to ambient temperature before cleaning, and avoid using compressed air or heat guns that can cause rapid thermal cycling. Understanding polymer requirements becomes critical as more manufacturers incorporate these materials into their designs. But even when using the right chemicals, applying them incorrectly can cause expensive damage. Number 3. Using harsh chemicals that destroy modern finishes and coatings. The matte black coating on your modern rifle barrel is not paint. It is a specialized treatment that can cost hundreds of dollars to apply and provides critical protection against corrosion and wear. These advanced finishes and coatings represent some of the biggest improvements in modern firearm technology, but they require careful maintenance to preserve their protective properties. Modern firearms use an array of specialized coatings depending on their intended purpose. Nitride treatments create a hardened surface layer that resists wear and corrosion. Cerakote and similar ceramic coatings provide chemical resistance and reduce friction. Physical vapor deposition coatings like titanium nitride offer extreme hardness and corrosion resistance. Each of these treatments has specific chemical compatibilities and vulnerabilities. The problem begins when gun owners apply traditional cleaning methods to these modern surfaces. Many older gun cleaning products contain acids, chlorinated solvents, or abrasive compounds that were formulated for uncoated steel surfaces. These same chemicals can attack modern coatings, causing discoloration, pitting, or complete coating failure. Acidic bore cleaners present a particular hazard for coated barrels. While these products effectively remove copper fouling from traditional steel barrels, they can etch or discolor specialized barrel coatings. The damage often appears as light-colored spots or streaks where the coating has been chemically attacked. Once the coating is compromised, the underlying metal becomes vulnerable to accelerated corrosion. Chlorinated brake cleaners and degreasers cause immediate damage to many modern coatings. These products, commonly used in automotive applications and sometimes repurposed for gun cleaning, can cause Cerakote and similar finishes to blister, peel, or change color. The damage is often irreversible and requires professional refinishing to repair. Even some products marketed specifically for gun cleaning can damage modern finishes if used incorrectly. Copper solvents containing ammonia can discolor certain coatings over time. Aggressive carbon removers may strip protective treatments along with the fouling they are designed to remove. The key lies in understanding which products are compatible with your specific firearms finishes. Military and law enforcement armorers who maintain large inventories of modern firearms rely on coating-compatible cleaning systems. These typically involve pH-neutral degreasers, specialized carbon removers formulated for coated surfaces, and corrosion preventatives that do not interact with modern treatments. They avoid universal solvents in favor of targeted products designed for specific types of fouling. The solution requires identifying these specific coatings on your firearms and selecting appropriate cleaning products. Many manufacturers provide compatibility charts showing which cleaning products are safe for their finishes. When in doubt, contact the coating manufacturer or a professional gunsmith familiar with modern treatments. The cost of appropriate cleaning products represents a fraction of the expense involved in refinishing damaged components. However, even the mildest cleaning products can cause damage when applied with excessive force. Number 2. Scrubbing aggressively with abrasive tools and techniques. The cleaning rod in your grandfather's gun cleaning kit weighs twice as much as your entire modern pistol. Those steel brushes and rough patches that maintained his battle rifle will destroy the precision surfaces and tight tolerances that make your firearm accurate and reliable. Modern firearms achieve their performance through precise manufacturing and specialized surface treatments that aggressive cleaning can permanently damage. Traditional gun maintenance emphasized thorough scrubbing to remove fouling and corrosion from relatively soft steel surfaces. Rough cleaning was not only acceptable but necessary to maintain function in harsh environments. Modern firearms use harder materials, tighter tolerances, and specialized surface treatments that aggressive cleaning can permanently damage. The most common damage occurs in rifle barrels, where aggressive brushing can remove throat and crown material that took precision machinery to create. Modern match-grade barrels have throats machined to tolerances measured in 10,000ths of an inch. A steel cleaning rod bouncing against the bore entrance can peel away metal, creating an irregular surface that degrades accuracy. The damage accumulates over time, gradually opening groups and reducing the barrel's precision potential. Pistol barrels face similar risks from aggressive cleaning techniques. The feed ramp area, where the barrel meets the chamber, requires smooth surfaces for reliable feeding. Steel brushes and abrasive compounds can create scratches and gouges that cause feeding problems or affect accuracy. Many gunsmiths report seeing expensive match-grade pistol barrels ruined by owners who scrubbed too aggressively while trying to achieve perfect cleanliness. Chamber areas are particularly vulnerable to cleaning damage. The chamber walls in modern firearms are often coated or treated for enhanced extraction and feeding. Aggressive brushing with steel implements can remove these treatments, leading to extraction problems and increased fouling. The chamber throat area, where the bullet transitions from the case to the barrel, requires especially gentle cleaning to preserve its precise dimensions. Trigger mechanisms in modern firearms use surface treatments and precision fitting that aggressive cleaning can disrupt. Many modern triggers achieve their crisp feel through specialized coatings applied to bearing surfaces. Abrasive cleaning compounds or steel brushes can remove these treatments, increasing friction and degrading trigger performance. The precise engagement surfaces that provide safety and reliability require gentle cleaning to maintain their original specifications. Professional competitive shooters and military armorers have developed cleaning techniques that emphasize chemical action over mechanical scrubbing. They use appropriate solvents to soften fouling, allowing it to be removed with minimal mechanical action. Bronze brushes replace steel implements for routine cleaning, and plastic or wooden scrapers remove stubborn deposits without damaging underlying surfaces. The modern approach to gun cleaning prioritizes patience over force. Allowing proper solvents time to work reduces the mechanical action needed to remove fouling. Multiple light cleaning sessions prove more effective and less damaging than single aggressive sessions. Soft patches and appropriate tools preserve the precise surfaces that make modern firearms accurate and reliable. But perhaps the most destructive old habit involves a substance that every gun owner uses. Number 1. Over-lubricating with excessive oil and grease. If a little oil is good, more oil must be better. This logic, passed down from generations of gun owners who maintained simple mechanical firearms, becomes destructive when applied to modern precision instruments. Today's firearms achieve reliability through precise tolerances and engineered clearances that excessive lubrication can compromise, attracting contaminants and creating the very problems that lubrication is supposed to prevent. Modern firearms are designed to function with minimal lubrication applied to specific contact points. Engineers calculate the exact amount of lubricant needed for each bearing surface, taking into account the weapon's operating environment and maintenance schedule. Adding more lubricant than specified disrupts these calculations and can actually decrease reliability and performance. The primary problem with over-lubrication involves contamination attraction. Excess oil and grease act as magnets for dust, dirt, and fouling particles. In dusty environments, over-lubricated firearms quickly develop a paste-like mixture of oil and contaminants that clogs mechanisms and causes malfunctions. This contamination occurs much faster than most gun owners realize, often within the first few rounds fired after cleaning. Trigger mechanisms are particularly vulnerable to over-lubrication. Modern triggers achieve their crisp feel and consistent break through precise engagement surfaces that must remain clean and properly lubricated. Excess oil migrates into trigger mechanisms, attracting carbon fouling and creating a gritty paste that degrades trigger performance. The contaminated lubricant can cause trigger creep, increased pull weight, and inconsistent break characteristics. Gas-operated firearms face specific challenges from excessive lubrication. Over-oiled gas systems collect fouling at an accelerated rate, as hot gases carry carbon particles that stick to excess lubricant. The gas ports and tubes that meter operating pressure become clogged with contaminated oil, leading to short cycling and reliability problems. Some modern gas-operated firearms are designed to run nearly dry, with lubrication only on specific bearing surfaces. Bolt actions and other manually operated firearms suffer accuracy degradation from over-lubrication. Excess oil in the action can migrate onto the barrel extension and chamber area, affecting bullet release and accuracy. Oil that reaches the chamber can cause pressure variations as bullets travel through the contaminated bore. Precision shooters often run their bolt-action rifles completely dry except for minimal lubrication on bearing surfaces. The storage implications of over-lubrication create long-term problems for firearm collectors and occasional shooters. Excess oil migrates through firearms over time, potentially reaching areas where it can cause damage. Oil that seeps into electronic components, optics mounts, or trigger assemblies can cause corrosion or malfunction. In storage, excess oil attracts dust and creates contamination even when the firearm is not being used.